Hey everybody, and welcome back to basically the finale video for your first 60 minutes of motion matching, or with motion matching, however you want to call it, where basically we are now on the final part where we will be fixing up coverage with animation warping. So basically in this section, what we are going to be going over is setting up our orientation warping. And if you've played with the game animation sample project and have seen the motion matching node, the internal workings of that, you will have seen the animation warping and what it does. And in my Gasp from Scratch animation blueprint series, I have went over what this does in there, but I will also be going over what it does in this video as well. In more of a simple fashion, we may not go through all of the bits, just because I want to keep this simple in relation to kind of what this is having us do or change or modify, stuff like that. But, we're also going to be taking a brief look at the reset root node that they're going to have us input in there. And then, finalizing some other stuff like doing the leg IK. But what I'll probably do for this one is I may not add this into this video. And the only reason I'm not going to, or, I guess I could do that. I could probably definitely do it in this video with the leg IK and like the simple explanation of like what it does and stuff like that. And, kind of what's going over that. But, what we're also going to be looking at too is the stride warping node, which was funny because in my current project that I was working on, which, I'm kind of copy and pasting it to move over to the new project for the tutorial and stuff like that, is I forgot to actually implement this and haven't really been able to do much research, but I do have some kind of points that we're going to go over in regards to these that I found out, but there's a lot more to the internal workings of that. So I'm at least found some information on kind of like what this section is doing, but I'm probably going to have to make a separate note video or comment in relation to kind of like what more this does. But for the most part, this actually seems to be a very cool node that is surprisingly not used within the game animation sample project. So I found that kind of interesting. And then lastly, like you will see this stuff where they try to set up displacement speed and world location. I will not be setting them up in this video, just because you can kind of see where it wants you to, I guess, try to use it. But the thing is like, they'll say we need a variable to drive the locomotion speed. So, that's why they created the displacement speed, but then they don't reinsert it into this, or at least demonstrate that. But I also found a better method of just tying this into something in general. So I will not be doing this part right here. We will just be ending at stride warping and whatever I set it to, right? So let's go ahead and get started. And preemptively, what I want to do is, preemptively apologize for any sort of like lagginess that may occur in this. I know for some reason in my last video that there were some lag occurring and we were constantly stalling out. So I think whatever happens, if it happens multiple times in this video, I probably will try to cut snippets out just to kind of like further progress it, so we're not constantly sitting here with a stalled save, right? So again, let's go ahead and get into it, and we are going to now touch base in our motion matching node. So when you're ready, let's go ahead and hop into motion matching and get this started. So what I would like to do first is I'm going to set these up bit by bit and explain them. So, right here with the blend stack input, right? So we're going to go over this part first so that I can explain what the blend stack input does and output pose does first. And then we're going to go over the orientation warping first, go over those settings and set that up. And then we'll move on to the next part, explain that, move on to the next part, explain that, just so I'm not having to put everything together and then having to explain everything that we've done. So let's go ahead and get into it. So with the blend stack input, what this is doing is think about with the animation state machines, right, that you've seen when you start up a blueprint, default third-person template, stuff like that, where you'll have noticed like the state machines where you have main states and locomotion and stuff like that. But then when you look inside these state machines, that you'll have seen like an input node where you drag off of, and then that's where you would create a state machine that's like idle or, walk slash run or jump, stuff like that, right? So it's basically similar to that, in which case this serves as a starting point of your animation blend stack and then goes through. And this, what it does is allow you to input various animation poses and sequences that will be blended together based on certain criteria. So it'll take your animations, the animation data and all the other all that jazz, and then it'll push it through the pipeline to whatever nodes that we set up in the, with inside that meets criteria, makes modifications, changes, whatever, and then put it into the output pose where, the output pose is the final node that outputs the processed animation pose data that is ready to be rendered for our character. So it basically, this represents the culmination of all the blending and adjustments applied in the previous nodes that we'll be setting up, that we will be setting up in here, which will produce the character's final animated state. So yeah, see, as you can see here, we're stalling now. So like I said, if that happens a bit too much, and especially if it gets too long, I will probably cut those out. So, kind of bear with me on that. So, but to go into it, the first thing we're going to do is let's go ahead and drag this out a little bit, and let's go ahead and disconnect the pin first. So what we're going to do is we're going to grab orientation warping right here underneath skeletal controls and go ahead and plop that bad boy in. So with this, what we're going to do is let's go ahead and hook this up, because I want to explain these components to you, right? So as you can see, that as soon as we hook them up as such, that we get two nodes, right, that we didn't even ask for. So basically this is like a conversion where you have local to component and component to local. So think about this in terms of like, how you've done a print string where you want to try to print off data, whether it's a Boolean to a print string, velocity to a print string, ground speed to a print string, stuff like that. But then you have that like little node that pops up that gets, helps attach the, whatever you're trying to define in the print string, data and whatnot. That's basically what is similar to this, where it's doing a conversion to help pass in our data and stuff like that. So basically what the local to component does in this aspect is that it converts the animation data from a local space of the skeleton relative to the character's root to the component space, which is relative to the game world. This transformation is essential for accurately applying subsequent adjustments that depend on the character's orientation and position in the world. So then once it does that, so basically it converts it from, again, our character's like relative skeleton to our, our component space that's relative to the game world. It then processes all that stuff in. So basically it's like zooms into our character and process whatever it has to do within our character before basically coming back out, right? Because then what the component to local does is that this converts the animation data back from the component space to local space. And this transformation is necessary after making whatever adjustments in the component space, preparing the data for the final output of the character's local coordinate system. So that's what it's doing, is it's basically taking it from, so in a better sense or a better explanation, it's taking it from the world into our character's components, making the modification, and then going from the character's components back out into the world, basically. So it you could see the proper animations or whatever played out into the world space. So that is essentially what that's doing there. So as far as what we're going to be setting up in here, so if I bring this back over and expand it, right? So when we look at the orientation warping, essentially what we're going to be adjusting is this section right here, where we're going to be, changing up some pins and stuff like that so we can represent it to look like this. And also what we're going to do is tie in the velocity a little bit differently, because we have try get pawn owner, get movement component, and then velocity, but we're going to do it a little bit differently, because even though we have try get pawn owner, you can definitely do it to where it's like try get pawn owner, get velocity, because this was not available for me as such like that. So I ended up having to put in the character's variable velocity, which still works. It definitely does that. And then also too, in that regard, you know, it should also work on other character aspects like AIs, NPCs, stuff like that. However, you got to remember that when we started this series that we had changed up to just cast to our BP third person character blueprint. So the other characters like, you know, NPCs, bosses, whatever, also need to be like a child of something, or at least utilizing the BP third person character to also use our animation blueprint. So you do have to be careful of that. If you did make a one size fits all where you did the cast a character and then manage to get, you can definitely get this stuff off of it, which will then work for literally your NPCs, your AIs and stuff like that. But again, it depends on how you set up the character reference, how you're calling your variables and other stuff. But like I said, in the beginning of the tutorial, we had casted to our BP third person character. So basically we are hard setting it to where our animation stuff only works with our BP third person character unless you give your NPCs, bosses, whatever, in the BP third person character blueprint, essentially. So let's go ahead and get into this and set this up and discuss the settings in regards to that, right? So what we're going to do is we're going to change our manual into graph, and don't worry, I'm going to go over literally what all of these do. Let's just go ahead and make these setting adjustments first. So then we're going to basically leave these alone, right? And then with our min root threshold, we're going to keep that the same. But then for our angle, they kept this at 90, but there is a thing that I like with the game animation sample project where I went ahead and changed this to 135 degrees. And there definitely is a reason for that, and I will explain it, you know, because we're going to go over all of these settings and I'm going to explain it in more simple details and why I set it that way. But yeah, so then what we're going to do here with warping space is we're going to set it to the root bone transform. So as you can see, apply warping relative to previous frames root bone transform, you know. However, they have it set to this, but this works best with if you have the offset root bone node set in your anim BP. So if you've ever messed with the game animation sample project, or at least have watched my series on it, you'll have seen us make the root bone transform, and then we created a function that we bound to the warping space that either gives us component or root bone. So for this instance, what I prefer doing is keeping it to component transform. So like, you know, like I said here, use this mode when using an offset root bone, which allows you the root bone and component transforms to differ. You know, like I said, unless we set up the offset root bone node, I do not recommend using this, so just keep it to component transform. It still works just as well. So now what we got to do for our orientation warping node, so let's go down to our settings, and what we're going to do is we're going to set 5 index placements here because we want to get all of our spine bones. So to figure out what our spine bones are, right, we're going to go up to here where you see the blue icon for skeleton, and we're going to click that and open it up real quick, just briefly. And this might take a while for me, so I'll basically cut to when it opens up for me. So I'll be right back. Oh, never mind. I won't be right back. So nope, it was shorter than I thought. So basically, right here, you can see all the spine bones underneath the pelvis, because the pelvis is the overall arcing bone of the entire hierarchy, because you could see like where it's placed. So this is kind of like our center of gravity pretty much, but then you could see where the spine bone one starts and how it works our way up our character for our spine to be manipulated and moved around or animated. So what we need to do in the orientation warping is set all of our spine nodes here, because this is what helps with our orientation warping. So with that being said, go ahead and close out of it. And what we're going to do is go back to spine bones, and we're going to set up 5 array elements. So from 0 to 4. So when I said 5 array elements, but in programming, what this is doing, so when you have index 0, index 1, index 2, 3, 4, you know, to pull up, let me pull up a notepad so I can briefly explain what it looks like, right? So if I go ahead and clear this out, so say we had an index and we're going to call it this, right? So we're going to make it look like this. So we have spines or spine bones, just like that. But then we have it equal, but then it's to an array of objects within the spine bones. So as you can see, I put it in brackets. So essentially this is how an array works kind of in Python, where you would set it in brackets and then you put your objects in there, right? So basically if I set up like spine 01, spine, let's see, 02, spine 03, spine 04, whatever, you know, I'm not gonna put all of them in there just because I don't want to waste your time with it. But basically this is how the array looks like. So in a coding programming aspect, with how this looks visually, this is how it would look like in the back end if you were actually kind of like programming it with Python, where what they do in programming is this first object that is in the array, they mark it as a 0 to start off with. And what they do it off of is, if you ever learn like IT aspects or computer science aspects where they kind of go more in depth with this. So since I do have IT experience to a certain degree, because my career is in cloud technology, stuff like that, but I'm not going to sit there and, showboat it, brag about it, whatever. But basically with my understanding, due to my history, my career, is that there is a form called base 10 within the computer science world and the IT world, where a base 10 is basically, think about your it's basically a series of 10 numbers that you would define, like basically how your normal like numbers go, like, right, you'd have your 1 2 3 4 5 6 7 8 9 10. That is a base 10 system. So like, it goes up by like every 10 before it changes over to like something else, right? So, but however, in the computer science world or the IT world, the base 10 system actually starts at 0 and then goes 1, 2, 3, 4, 5, 6, 7, 8, 9. Because think about it on your keyboard, right? Look at your number pad on your keyboard and tell me if you see a number 10 before you have to start going up to the next digit, and you have to then do, you would have, again, right here, this 1 right here, right? So like I said, look at your keyboard and tell me if you see a number 10 key on your keyboard. This is basically the base 10 system, because then we can start actually making numbers like 10, or we can make numbers like 25, or numbers like 64. But then notice how if I get to 100, how we still have our base 10 system, but because we utilize the base 10 numbering system up here, we can create the number of 100. So hopefully that makes sense. So when you look at it in this system with our base 10 system, and hopefully by seeing it laid out like this, you can see how an array would form, right? Because say we had spine 1, so that is our 0 placement, or our index 0, and then spine 2 is our 1, which is our index 1, and so on and so forth. So then you would have spine 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's basically like off by 1, but again, like the best way to understand the base 10 system and why the index starts at 0 is like, look at your keyboard and look at your number pad, and you tell me if you see a key that says 10. You will not see that, but you will see 1 and 0 on your keyboard, and by utilizing those you can create the number 10. So, but it's also kind of a bad analogy, because I don't want you to also think about that, but in a very simplistic way of visualizing it or trying to understand it, look at your keyboard, and that's basically like how the base 10 system is set up with computer logic, or under the computer, stuff like that, right? Like within the back end stuff. So that is essentially how it basically is. So in that case, that's why even though we see 5 array elements, it starts from 0 and goes to 4. But enough of that. Let's go ahead and set up our spines with it. So go ahead, and what we're going to do is each one of these, we're going to set up our spines. So, you know, from 0, we're going to set spine 1, and then 2, 3, 4, and so on and so forth, right? So go ahead and do that until you have all 5 spine placements, and then we've basically set up our spine for our orientation to work across like our spine or the entire back portion of our body, stuff like that. Now for this one, we need to grab our IK foot root. So this one's actually pretty simple. You just need to come in here and look for IK, and then you should see IK foot root. So you go ahead and click it and click that and add that into there. So now we need to add our IK foot bones, and we only have 2 feet, right? Or, you know, 2 footsies, you know, however you want me to explain it. Like you can see right here, we have our left foot, we have our right foot. So basically in this context, we just need to add our IK foot bones there. So similar process to the foot root is we're going to type in IK, and then you can see right here, foot left and foot right. So we do need to just go ahead and grab those, just like so. So now I have IK foot L and IK foot R. So it knows where our feet is. It knows where our spine is due to that. It knows where our foot root is, which would be like right here in between, stuff like that. So now we got that set up. So now pretty much everything else is going to be left at default. I'm not going to touch the rest of this, but like I said, I will go over what all of these do. So don't worry about that and fret about it, because I will make sure that you better understand it. So, but in regards to that, the last thing we're going to do in what I plan on doing, since we have specifically casted to our BP third person character, is in your orientation warping. What we're going to go ahead and do is I'm going to get our direction, they want us to do velocity, right? So if I pull back over the game animation sample project, or not the game animation, your first 60 minutes, right? Where you can see that they have the velocity to get our locomotion direction, right? However, you don't really see, let me see if they see it, because I don't think they even explain it, right? Because what we're trying to do is we're trying to give our velocity to our locomotion direction. So it doesn't really explain it nicely in here as to why it does that. But basically, so let's go ahead and add it. Or yeah, let's go ahead and add it, and then I'll explain it, right? So hit the pin, and what we're going to do, I'm going to leave it as exposed. I don't really... Actually, let me unexpose, or no, we'll expose it. We'll keep it exposed. That way we can just literally call our velocity, and boom, we have it, right? So the reason why velocity is important in this specific instance, so let me explain what velocity does, because I know I've explained it a lot in my other videos, but I need to keep explaining it so that way I still understand what it does, but also to make sure that everybody else still understands what it does. So velocity in a math sense basically means, and actually, you know what? It'll be better if I pull up paint, right? It'll be much better if I pull up paint. So with velocity, what it does is imagine you are going 50 miles per hour or kilometers per hour, however you want to interpret this, right? So we got 50 miles per hour, but then we are going east, right? So we're going east. And so basically what this is our 50 miles per hour is our speed, but east is a direction, right? So what velocity is your speed plus the direction, right? So if I'm going 50 miles per hour eastward, so this direction at 50 miles per hour, then that is my velocity, because velocity means your speed and a direction. So then, you know, in regards to that, so like if I get rid of this, I probably should have used Paint 3D. Paint 3D would have been a much better thing for me. So if I would have went, if I say I'm going, so like, you know, let's ignore this for a moment, right? Or I like how my pencil shrunk. There we go. So say we're going northbound, right, at 85 miles per hour or kilometers per hour, you know, whatever, right? Well, then that is our velocity, is we're going northbound at 85 miles per hour or kilometers per hour, you know, however you want to interpret that. So that is what our velocity is. So that's why if we look at our if we look at our locomotion direction, we are trying to get a direction, and our velocity helps get that direction in a very simple form. Because think about it, when you get if I can get my words out, your velocity is a vector point that consists of 3 points on 3 sides of the graph, right? You got your x, your y, and your z. So your direction would either be you're going, 500 centimeters per second on the x-axis, or 700 centimeters per second on the y-axis, or maybe you're going 400 centimeters per second on the z-axis. That is what this is trying to grab specifically, is how fast we're going and what direction or what axis are we traveling along. So that's why velocity helps in this aspect for that. So that is pretty much it for that. So now to kind of go over the main points with our orientation warping, right? So if I go back into it, so let's look over our evaluation section first. So you see we have mode, which, is our evaluation mode, which either comes as graph or manual. So we want to specify graph in here, because what this means is, so we're trying to define or specify the evaluation mode, and we set it to graph, meaning that it dynamically calculates, the stuff that gets put through the animation graph, rather than being a static setting that we would have to set via manual, because we don't want to set all that stuff up. We just want to grab whatever data or animation data is being passed down the pipeline and grab it in here using graph to basically dynamically calculate everything within here, make the proper adjustments to what we have set, stuff like that. So that's why we need this to be set to graph. Then we have the locomotion angle, and we are setting it to 0 because we don't really have anything for it. But basically, and also too, we're not changing it accordingly to your first 60 minutes of motion match, or this is how it was set in motion match, this first 60 minutes. So what this means is that this is the initial angle for locomotion. So as you can see here, the character's locomotion angle relative to the specified rotation axis. So it's the initial angle for locomotion, and we're just keeping it at 0.0, which means that the character will not start with any angle offset. So this value will change dynamically as the character turns. So that's why we also place the spine bones, so that way it properly angles our character according to our locomotion. However, in a later video, we will be looking at lean offsets, so do not worry about that. Then, as I said, we did our locomotion direction, and I went over what that does. So, like I said, so initially before our velocity starts, this is set to 0, 0, 0, which defines the initial locomotion direction vector. So, with it being 0, 0, 0, there is no directional offset, which allows the direction to be updated by our character's velocity or our movement direction that we're getting from here. Then we have the min root motion speed threshold, and essentially what this does, as you can see, we have it set to 10. So this sets the minimum speed required for orientation warping to activate. So with us setting it at 10, orientation warping won't apply unless if the character moves slower than the speed, to avoid minor or unnecessary adjustments. So with this, we can set it higher, lower, however you want, but also think about it in this aspect too, right? Remember our pure thread save functions that we made and how we set a threshold to 10 in there? Well, we have our 10 in the, is starting, so that way we know to play out certain starting animations there, but then 10 while, greater than 10 while we're moving. So we want more of our orientation warping to try to match the is moving part of it. So we don't want the orientation warping to kick in until we are above 10 centimeters per second. So you kind of want this to match whatever value you have set, or the ground speed you have set within your is moving function. Or that's a better correlation of doing it. Other than that, if you had a bunch of other factors set into the is moving one, then this is pretty much unnecessary to think about it or correlate in that aspect, but we would still want it to be like a relatively small value, so that way we don't have any sort of like minor or unnecessary adjustments before we actually get up to a proper speed. So then we have the locomotion angle delta threshold, and what this does is this defines how much of a difference or change, like in degrees, there needs to be between the current angle and the target angle before orientation warping kicks in. So For this, I straight up copied the game animation sample project at 135 degrees. So with this being changed like that, what this is doing is, like, since it's set to 135 degrees, the character will only adjust orientation if the angle difference is significant, preventing small and unnecessary movements. So this will more or less like kick in when we start doing movements, when we start aiming around or doing our lean offsets and stuff like that, where the degrees and anglings become more important. But other than that, don't worry about this for the moment. And then we have our warping space, and like I said, we kept it at component transform because the root bone one is unnecessary unless you actually place that node in your animation blueprint. So with this, basically what it's doing is it's defining a space for warping, whether it be our component or root bone or, you know, a custom one like that we make like in a world or local setting maybe. But the component transform, what this does essentially is that this applies warping relative to the character's component space, which is typically tied to the character's orientation within the world, which is what we want at this moment, and unless, like I said, you add the offset root bone node. So then let's go ahead and go down to our settings and let's talk about our spine bones once again, or at least in a better, broader context. So again, what the spine bones does here with our array of elements is that we list out our bones in the spine that should rotate during orientation warping for a smooth upper body turns. So we have the individual bones placed here. So what's going on here is that we have it placed from our lower spine to our upper spine. So what this will do is adjust the bones to let the character's torso turn more naturally without rigid or unrealistic movements. So that's why we specify the entire spine of our character, so it orientates more realistically as our character moves throughout the world. Then we have the IK foot root bone, and that we've set to IK foot root. So what this is doing is it specifies the base bone for the inverse kinematics of the feet. So here we have it set to the IK foot root as the anchor for our foot adjustments, which helps maintain the character's balance when rotating. And the root bone of the foot, I believe, is right there. So if we go into here and to check it out, and if this takes a while, I'll probably end up cutting it. So actually, just in case, I will be right back just in case this does take a while. Never mind. It comes up pretty naturally. There we go. I'm glad that's working. So I guess I just have to threaten it with a clip and it'll work. So if we look at where the IK foot root is, you could see that it's placed like dead center in between the feet. But what it's doing is you could see that it's getting the IK foot root here and placing it out to there. So basically they're just sub bones to the foot root. But yeah, you can see where it's like dead center there. So it basically helps keep our character's balance there at that center. So that's why that's important. And then our IK foot bones, that's tied to that foot root as you just saw, right? So we have our individual foot bones here used for orientation warping, and these bones help ensure that each foot adjusts independently and accurately in response to our rotation. So that's important there. Then we have our rotation axis on, and basically what this is doing and why we're going to keep it at Z is because we want it to, basically our axis to rotate along the Z, or basically our yaw, which means that we have like a vertical rotation, meaning that the character twists left or right. So basically when you look at it, it's like the character twists this way or that way, you know, around the Z. So what this does is it's basically helpful for orientation adjustments. Then we have distributed bone orientation alpha, and we have it set to 0.5 in here. And what this does is it defines the distribution amount for spine rotation. So with us having it set to 0.5, half the rotation is spread across the spine bones, creating a natural rotation effect throughout the torso. So, you know, if you change the numbers accordingly to like closer to 0, closer to 1, you can end up throwing off, you know, certain balances and stuff like that. But maybe it could be something that you want to do, depends on like what you're setting orientation warping to, right? Then we have the rotation interp speed, and we have this set to 10. And what this is doing is that this sets the speed of rotation interpolation. So in value of 10 means moderate adjustment speed. smoothing out turns without sudden or jerky movements. So basically what interpolation is doing is if you go from, so what interpolation does, and let me bring back up Paint, but I'm going to bring up Paint 3D because I really just don't want to use Paint. I think it's bad. So imagine you have point A right here, right? So you have point A, but then you have point B right here, right? So interpolation is going from here to our B, but we're doing like best guess data along the way, which gives us our result in going from A to B. So that's what interpolation is all these little points like in between that helps guide our line using, you know, and I wouldn't say precise, but like accurate data collection to go from point A to point B. So that's what interpolation is doing. So again, with us doing it here and we set an interp speed, basically we're just setting the speed at which that interpolation happens or the rotation happens so we don't get sudden or jerky movements. Then with our max correction degrees, and we have it set to 180 here, is that this specifies the maximum degrees of correction. So at 180 degrees, it allows a full backward rotation if needed, letting the character reorientate completely if they turn around. So it basically allows us to have a nice smooth like 180 degree turn if, you know, with corrections. But if you exceed that, then that's where we can start getting like jerky, clunky, like whatever. Then we have this right here where we have the max root motion delta to compensate degrees, and we have it at 45. So what this is doing is that it caps the adjustment of rotation for each frame to 45 degrees. This gradual adjustment keeps movement smooth and avoids sudden position shifts. So it just allows us to like, you know, gradually smoothen out our movement and position shifts at, you know, upwards to, and it caps that adjustment up to 45 degrees. So, you know, if you go any faster than that or whatever, again, you can run into some problems with, you know, the clunkiness, stuff like that. So then we have counter compensate interpolation by root motion. And what this is doing is that by enabling this to true is that we ensure that the rotation is counterbalanced by root motion. So if the character is moving, the orientation warping doesn't create awkward rotations that affect the character's flow. So you definitely want to make sure that this is definitely checked, especially if you're using root motion animations. So then I'm going to kind of skip over the debug because this is just kind of like debugging stuff from there, and we don't need to be really concerned about this. However, if you would like me to explain it, I can, but there is in my animation blueprint series, I do briefly go over this in one of my videos. So I'm not going to necessarily focus on this because I would like to more or less focus on the experimental part, as you see right here, because this part's pretty interesting. So with the scale by global blend weight, so what this is doing, and while this is set to false and we make no changes here, is that, you know, if it were to be true, this would scale the orientation warping based on a global blend weight, reducing the effect as blend weights decrease. But we have it disabled here for a consistent warping effects. So we don't really need to worry about this unless you start having like blend weights and other stuff added onto your character, which you would be creating in your skeleton mannequin. Then we have the use manual root motion velocity, and this is set to false. So what this does is it by us having it as false, it disables the manual control over root motion velocity, meaning the engine automatically calculates it. This helps reduce the complexity by using the character's natural motion. So unless you really know what you're doing or trying to set up, there is no reason to have this checked, because then you also have to set it up here. So even if you have complicated checks with using a bind or just having it on here, but then you have to set it up here, which is again unnecessary, because then what this does is it sets the custom velocity for root motion, but it's disabled, you know, via here. But, you know, so with a value of 000, there's no extra manual velocity applied, so the engine calculates motion speed and direction dynamically based on what we already have set up elsewhere. So that is basically it for motion warping or orientation warping, and as simple as I can make it. So now let's go over the other part where we are going to set up the next thing, which is our reset root transform. So let's go ahead and grab this stuff and move it over here. And we're going to then plug this in. We're going to drag the out from the orientation warping and get the reset root transform node. So as you can see within here that we don't have much settings like in our stuff here. So there's not really much to talk about in here or to adjust, but basically what the reset root transform does here is that it resets any transformations applied to the root bone of our character. So this step ensures that the root remains in a consistent state, preventing unintended shifts or rotations that could misalign the character's position or orientation. So this is actually very important to have if you are doing motion matching, animation warping, motion warping, orientation warping, whatever, just so that way our character gets reset and back down to what it originally should be, you know, when the pipeline loops back around. So this is actually very important. So with that being said, we got one final part to go over, which is essentially our, our stride warping node. So when we go into here, let me go ahead and pull this back over because we are going to set this up next and we're going to briefly go over it. But I want to, while we're in here, I want to set up the stride warping because this is interesting from what I've gathered or what I could find on it briefly, especially with the changes of what we're doing here. There is more stuff, but I do have to go over it and see what these do because there is stuff under advanced, like I will show you, but I don't have a good explanation for them right now. So with our stride warping, as you can see, it's like even though we're so what it's trying to do here is it wants to clamp our strides to our locomotion speed, you know, which with doing that, as you can see, clamping the velocity at which our character can move, we can still end up with foot slips at certain times. So when the character is starting, stopping, or accelerating between walk and jogs or back again, to fix this, we can use stride warping. So it doesn't go more into what that does, but what I could find on it. So if I go back to what it does, let me pull up my notes real quick. So what the stride warping node does, or at least let me move this back over and let's go ahead and apply it real quick. So drag off your reset root transform and get the stride warping node just like so. And what this does is that it dynamically adjusts a character's stride length to match its movement speed, ensuring natural locomotion without foot sliding. So that's what was really impressive to me about this is I think what I'm going to try to do is I'm probably going to introduce this as a gasp tutorial in the future as I find more stuff about it. Because as you can see, we have bind values, but I don't know what these actually take as far as the strides and other stuff goes, but it helps with floor sliding. But here's what I was talking about with the advanced, right? There's more stuff involved with it that I need to go over because this could actually help with a lot of cool things that I never knew about before. However, the main part that spoke out to me about this is that this can help with foot sliding. So like, I'll give you an example, right? So let me go ahead and pull over my other project so I can show you, right? So, you know, I have it set up in here and we're going to go ahead and set up the stuff, right? But when I go ahead and hit play and wait on that. Well, if I threaten it again, there we go. So when you pay attention to the feet when you watch my character move, right? So as you could see, even with diagonal movements, which I've known to be a huge problem when it comes to motion matching, especially since it's in gasp as well. But look at the character's foot very carefully because we do have a lot of foot stuff going on because in this project I have leg IK, I have foot placement, and then I just added stride warping, but you'll notice that there's no sliding. You'll notice that it's like, think about it, look at my character's feet and think of an angelic choir coming down and gracing my feet. Like, this is actually pretty sick if I can figure out more information in regards to this, because ever since I implemented it into this, the character surprisingly does not foot slide when going in diagonal directions. It gets a little bit wonky, sure, because of how the animations and stuff are set up. Because again, look at how we have like our, you know, orientation and strafing, right? It only has like one method basically. So I can understand why this back here part is like a mess, but going this way is fine. Going this diagonal direction's fine. Going this diagonal direction's fine, you know, etc., right? So to me, that's pretty cool and shows a lot of promise and potential. So I really do like that. All right, cool. All right, so then, yeah, let me go ahead and move that back over here. So now what we're going to do essentially here, and we're going to set it up like how I have it in my other project, just so that way we can kind of go over some of the stuff that I could find in regards to it, right? So let's go ahead and click on our stride warping, and what we're going to do is we're going to switch this mode to graph, so that way we can change these things right here. So what I ended up doing, so again, if we bring over the let me find it, the your first 60 minutes of motion matching, you could see that when we get into here to the stride warping, you'll say we'll need a variable to drive the locomotion speed input, add a new float variable called displacement speed, and a vector variable called world location. I'm not doing that. I'm not going to do that. I think it's not, I don't know why they do it here, but it doesn't make much sense to me, especially when we're trying to get the actor location and then whatever they have the world location set to, which you can see right here. You know, we have the what is it, get owning actor location here, and they probably have something further down that gets like the world location, but this doesn't really make much sense to me as to why they're doing it here, especially when you have a safe divide and they're dividing it by delta time. Like, I can kind of get it, but at the same time, it's like if we're trying to clamp or at least like reduce the what do you call it, the foot sliding and stuff like that based off of our speed and stuff like that, to at least match our character stuff, then I feel like it's better to add a our ground speed to it, right? Because we want to clamp it to that. So for this, then what I did was our locomotion speed, I clicked in our pin right here, and I just came down and grabbed our ground speed, and that's pretty much it as far as what I set it to, right? So now you can see that there is a familiar evaluation detail right here. So if you remember what we went over here with our minimum motion root matching speed, is that this defines a speed, you know, that will, you know, sets our minimum speed for basically for our stride warping to activate. You know, so if the character's below this speed, stride adjustments won't be applied, just like the orientation warping. But if we're above the speed, then the stride warping does apply. So that is important. Now, with the other parts, we got the pelvis. So the thing that I can gather from here is obviously connect your pelvis bone to the pelvis setting. And then the IK foot root bones, we want to go ahead and grab our IK and look for our IK foot root here and place that in here. And then for here, we need to grab our foot definitions. And again, we only have 2 feet. So let's go ahead and make 2 array elements. And you'll notice how we have to get our IK foot bone, and then our forward kinematics foot bone, and then our thigh bone in here, which I was like, you know, I'll explain these parts once we set them, right? So what we're going to go ahead and do for our IK foot bone, or at least our index 0, is we're going to look for our IK and get our IK foot L to start off with our left foot first. And then for our forward kinematics foot bone, basically when you see FK, you're going to set it to the foot of the IK that we set here. Since we set it to IK foot L, we're going to grab our foot L and place it to the forward kinematics foot bone. And then for our thigh bone, we're going to set this to match the side that our feet is on. So we're going to get thigh L for here and set it up just like that. And then now in our index 1, we are going to repeat for the right foot. So we're going to look for IK and we're going to get the foot right. And then for our forward kinematics, we're going to get our foot right. And then for our thigh bone, we are going to get thigh R right up here. So again, so what we're going to also do here is I'm going to set these to true because that's how they had it set in the Your First 60 Minutes of Motion Matching. But other than that, I don't know what this other stuff does, so I am not unfortunately going to go over this in this video. However, I do have some information on this stuff, right? So if we go over our pelvis bone stuff, so, or at least our, stuff here. So with our pelvis bone is that we're specifying the pelvis bone, which serves as a central point for adjusting our stride length. Then with our IK foot root bone, here we're defining our root bone for the inverse kinematic system of our feet acting as the anchor for our foot adjustments. So that's why that's important. And then for our foot definitions, that you'll notice how we have, IK foot left and right, foot left and right, thigh left and right, right? So the IK foot bone is controlling the foot placement for our, IK feet parts, right? Then the forward kinematics foot bone is representing our actual foot that it will be adjusting our foot placements with. And then the thigh bone, what this is doing is that, this is part of the extra stuff for the forward kinematics, so it knows how to go, do its proper thing throughout its leg. So that's what the thigh bone is doing there. Then we have the stride scale modifiers. So what this does is this controls how the stride length is scaled. So we have a clamp result, and in the first 60 minutes, they have both of these set as true, right? So for the clamp result, this is set to true to ensure that the stride scale stays within the specified limits that we've set throughout up here. Then the interp speed, or our interpolation result, not the speed, the interpolation result, this is set to true, so that way it enables interpolation for smooth transitions and stride adjustments. So this is actually very important. Then we have our clamp min max, and then our interp speed increasing, decreasing, right? So for our clamp minimum is this sets the minimum allowable stride scale, while this, sets the maximum allowable stride scale. So unfortunately, it's like I don't have too much information on it besides just getting that basic information for the clamps, but that's what that's doing there. And then for the interp speed, decreasing and increasing. For the increasing, this defines the speed at which the stride scale, increases. So once we hit 10, the stride will start picking up and increasing and get us our desired results. And then for the decreasing is that our stride scale starts decreasing once we hit back down to 10. So these ones are adjustable depending on when you want the stride stuff to start actually kicking in. But then again, you'll find all this other stuff under advanced, and like I've said, the other times, is that unfortunately I just don't have information on it, because I literally thought about it when I was going through this and pulling back up Your First 60 Minutes of Motion Matching, is I never actually set this, so I never actually got to do the proper research on this, so I don't know what all the advanced stuff does. But I can just looking at it, I can maybe take a guess at it, but I'm not going to because I don't want to confuse y'all. So for the moment, we're not going to touch on this stuff until I actually get more information on what this does and how it's helpful. So with that being said, we've officially set up our motion matching node, and now we can work on the final bit, and then I can declare this video done. So let's go ahead and do that. So let's go ahead and hop back into our anim graph whenever it's ready. Is it ready? There we go. Sorry guys, I was typing something over in my other slot for a moment. But so let's go ahead and go back into our animation graph. And let me see where I have it. It's going to be in between your pose history and our motion matching node. So we're going to go ahead and expand this out a little bit, or actually a lot more, because I forgot it's going to also give us our other nodes. So from our motion matching node, let's go ahead and drag out and get our leg IK, or actually, no, I'm sorry. It's not going to do that because this is going to do a local to component conversion, as you could tell by the animation how that's blue and these are white. So go ahead and plug that into motion matching and this other part into pose history. And let's go ahead and fix this up briefly before we talk about the leg IK. Just like that. So now with our leg IK, so with what this is doing, so we have a lot of like our other stuff in here with our stuff. So basically overall with what the leg IK is doing is that this is using inverse kinematics, which is what this is, you know, as a technique in computer animation, which allows for realistic positioning of our character's legs. So this ensures that our feet make proper contact with surfaces and adapt naturally to varying terrains. So, you know, unlike forward kinematics where each joint is individually controlled from the hip down to the foot, the leg IK enables, you know, animations to or like animators or whoever to specify the desired position of the foot, and the system automatically calculates the necessary joint rotations of the entire foot. So with inverse kinematics, so with forward kinematics, you have to actually adjust like each part of the joint or the thing or like wherever you're modifying to go from point A to point B. So if you were trying to make your character reach for a button and you used a forward kinematics thing, you'd have to individually modify every part of that arm to go from his like point A pose to point B where he's reaching out to touch the button, right? So that's what you'd be doing in forward kinematics or FKs. So the IK, where basically if your hand's to your side and you have to reach for the button, the IK, as long as you pass it in specific parameters, it will go ahead and do the adjustments for you automatically to try to smoothly transition your hand from your side to touching the button. So that's what that is doing. So with that being said, as far as the settings in here, so with our reach position in here, I'm trying to remember off the top of my head what this is doing, because the iterations here are basically how many times it's going to reiterate our settings in order for our thing to have like a precise like movement or smooth movement. So basically just think of this as like a looping operation that it goes through, like, you know, 1 through 12 before it circles back around for our animations to smoothen out. But I'm trying to remember what reach position is like off the top of my head, but it's not coming to me. But then the soft percent length, I'm actually going to adjust this to 0.99 to match the game animation sample project. But what the soft length does, or the percent length, is that this is helpful for your knees. Like, so it allows your knees to bend softly or slightly, you know, when your character's moving or going up terrain, stuff like that. So you want to set it somewhere between 95 to 99, because when you set it to 1, that's when it starts becoming like weirdly like stiff or have like a popping thing. So you can see right here, right, where we have range from 0.1 to 1.0, where when set the value less than 1, will softly approach full extension starting when the effector distance from the root of the chain is greater than the percent length of the bone chain, typically values around like 9.97. So this is useful for preventing the knee from popping when approaching full extension. So, but like I said, just in simpler terms, is this basically helps the knee for like, you know, smooth when you're walking and stuff like that. It allows the knee to actually animate nicely or smoothly without like poppings in the knee, stuff like that, especially if you're going up like inclines, like stairs, stuff like that. It prevents like that popping when going like full extending and stuff like that. So it allows the soft bend in our knee. So, but however, from what I remember from doing the game animation sample project from scratch, is that we want to set this value anywhere, like an appropriate value from like 0.95 to like 0.99 for a good, nice, soft knee, basically, or a soft knee bend. So then, don't remember off the top of my head what the soft alpha is doing, but we do want to keep that at 1 because it says blends the effect of the softness. But there's more going on to the soft alpha if I'm trying to remember, but again, it's not coming to me off the top of my head. So what I'll probably end up doing is making notes in the comment about what these settings do for the leg IK, or unless you do want to go and watch my game animation sample project from scratch, where I do discuss the leg IK in greater detail. However, with this, what we do have to do is we do have to set up our leg definitions right here. So as you can see, where we have to, you know, do a lot of stuff here or go over stuff here, I did forget that there was all these settings, so I don't remember where my notes are. I should probably actually look for my notes, possibly, but I went over the leg IK so long ago that I don't remember where I placed my notes. And I really don't want to take up your time. Let me see if I can search for it real quick within my OneNote. Leg IK notes. I may have just found it. Let me see if I actually found it. If it'll pop up for me, because I don't want to waste too much of y'all's time trying to look for this. So let me see. I think I may have found my notes. Yeah, I think I actually did. Awesome. Yeah, I actually did find it. Cool. So here we go, guys. I found my OneNote notes in order to be able to go over like what these are doing. So awesome. So with our reach precision right here, and that we have it set to 0.01. So what this is doing is this controls how close the foot needs to be to the target IK location before the system considers it done. So a smaller value means more precise IK placement, but it might require more processing time, which then the max iterations comes in. And what this does is this limits the number of times the IK solver can try to position the foot. So higher values give it more chances to get the foot in the correct place, but can take more time. So for us, the 12 is actually a very reasonable compromise between precision and performance. So then here we go, a proper thing for the soft percent length. So yeah, I remember setting it to 99. So this softens the leg stretch when the IK tries to move the foot to a target. So at 0.99, the leg is near fully stretched, but not quite 100%. So this prevents the leg from looking too rigid or unnatural when it reaches. So that's what that is doing. And then we have the soft alpha, which this controls the strength of the soft length. So a value of 1 means it is fully applied. Lowering this would reduce the effect of softening, making the leg behave more like a stiff rod. So we definitely want to have it at 1 on here. So now let's go ahead and put in our leg definitions before I go over what each of these things do from my notes. So let's go ahead and get our IK foot bones here. So we're going to start with the left one first, and we're going to search for IK, and we're going to get the IK foot L here. And then for our IK foot bone here, we're going to look for foot, and we're going to grab foot L. So now let's do the same for our index 1 and do our right foot. So let's go and look for IK and get the IK foot R. And then for our foot bone for our forward kinematics is let's look for our right foot here and set that as well. So now I'm going to go ahead and, collapse the index 1 because these settings are going to be the same for both of them. So I'm just going to go over what's going on here in this part, and it'll basically be the same understanding for the right one. So for the legs, right? So we got our foot because we're trying to designate our, the start of our foot chain and the endpoints of our foot chain. So with the number bones in the limb, so we're going to keep this set to 2 because that's what the default came with. And what this does is this indicates that the limb or the leg has 2 bones involved in the IK calculation, the thigh and the calf bones. So that's what is going on here, and it's getting that through these 2 points. Then we have the minimum rotation angle, and we're going to keep this at 15. And what this does is this is the minimum allowed angle for bending the knee. Setting it to 15 degrees ensures the leg can't lock straight but maintains a slight bend. Then we have the foot bone forward axis, which is Y, and what this does is this defines the forward direction of the foot. So here the Y axis is treated as the forward direction for foot orientation. Then we have the hinge rotation axis, and even in the game animation sample project, this was set to none, but basically what this does is since we have no specified hinge axis defined, this means that our leg doesn't have a strict rotational constraint like an elbow might have. So we're not constraining it to anything. Then we have enable rotation limit here. We're going to keep that as false. And what this does is it sets, since this is off, there are no hard limits placed, on the, how much the leg can rotate at the joints. So that is what that is doing. And then with the enabled knee twist correction, what this is doing is that we have this turned on to adjust the knee orientation automatically, ensuring the leg bends in a realistic way. So that's what this is doing here. And then for this curve is that there's a twist offset that you can apply, but this requires us to have a curve name of stuff like for our skeleton or a float curve and stuff set up that we would be calling in here to have a slight offset of our knee twist or correction. And since we have it none, there's not really much to really worry about in here. So I'm not going to really go over this deeply, since even the game animation sample project doesn't even have that enabled. But that is it for the leg IK node. So with me saying all that and stuff, I can go ahead and declare this essentially done. So with that being said, let's go ahead and save our compile and save our stuff. And now let's go ahead and play our character to see how everything looks now. Oop, I like how it's going to keep freezing up. Well, so now I got to figure out, okay, there we go. So now, as you can see, we have great movement, stuff's going on, everything's hitting just right. And yeah, you saw me T-pose while in the air because we don't have jump animations and stuff set, which is going to be, we're going to have a lot of stuff set up in our, actual next part of this series. But as you can see, we basically have now finished the entirety of the Your First 60 Minutes with motion matching. So what I'm going to do is I'm going to call this video the finale, since we managed to finalize everything in here. And then the next parts of this, what I'm probably going to do, I don't know if I should call it a new series. Oh, well, no, what I'll do is I'm going to rename the playlist series, but I'm going to call this the Your First 60 after edits, where we're going to be going over stuff like setting the jumping stuff up, as you can see here, because we need to set up trajectory collision handlings so we can get our time to land and some other stuff. And we are also going to set up other stuff like hand IK. We're going to be setting up our gun. We're going to set up some basic shooting stuff that does damage, some other stuff like that. So it's going to be a very cool tutorial where basically off of this, we are actually going to make a game, because there's also other stuff we're going to add too, like foot IKs and stuff like that. Because as you can see when you look at the ground, how our feet are floating, because the leg IK does not actually do a foot placement. We have to actually make the foot placement node, which also helps with warping our foot to the slopes. So there's going to be a lot of stuff that we go over there and whatnot. So also too, what I did do before I actually get off and end this video is let me go ahead and pull up my content drawer. One of the things I did change within my chooser table, because as you could see, I'm getting those weird glitchiness for our animations and stuff. So I think there's going to be more that I have to take care of and fix. But I did take these stops out of the stand rifle pose and, fix stuff up here. But then in our walks and runs, I did move the stops into here. I added the stopping column. And we have it true down in a diagonal fashion, with everything else being false in order to match everything properly. And I did the same thing with the runs. So in case that y'all wanted to do that, go ahead and do that. But other than that, I still got to figure out what is going on with the animation glitches that we currently see happening in there. But for the most part, that'll probably be an update video or something I do to actually, fix that once I figure out what is going on there. But other than that, ladies and gentlemen, we are essentially done with the Your First 60 Minutes with motion matching. So again, I'm going to call this the finale video in YouTube, but again, I'm probably going to change the playlist to, making a third-person shooter with Your First 60 Minutes of motion matching. So that's probably what I'll do, and then, the after series stuff, I'll figure out kind of what name and convention I want with that. But other than that, y'all have been great. I hope that this series has been educational for you and to show you the very basics of motion matching, or at least the way that is simple for me to understand and also get stuff set up. So, you know, I definitely appreciate the guy. Let me see who set this up. So if I scroll back up to the top of your first 60 minutes, I do want to give a huge shout out to, like, you know, Euan Carmichael. You know, he did a very good job with getting this set up and covered and going over like what we need, what we have to do, stuff like that. It's just that I took it and went in a slightly different direction or approach that seems a bit better streamlined for everybody else to be able to comprehend what is going on throughout this in a much different tone. Or I guess for me, I want to call it a more simpler tone, because, you know, I understand what's going on here, but it kind of confuses me without seeing it. But with Gasp, I'm not confused. But then, you know, with other stuff like how we set up the motion matching stuff, you know, we set our own pivots and our own start, stop, you know, loops databases. We briefly touched on the, you know, databases and stuff like that. We briefly touched on normalization set, you know, all this other sweet jazz. So all in all, in case y'all did not want to read this series is for y'all, but, you know, we are officially done now. We can mark this as done, and I give my kudos to the person that made, you know, the staff member that has made this exceptional you know, documentation for you to learn your first 60 minutes with motion matching. So with that being said, ladies and gentlemen, y'all have a great rest of your day and take care.